given the number of few days, we don't have any days before we take this exam. I have some extra review sheets up here, but everybody got one, so when those are gone, they're gone. And you guys need to hang on to your stuff. Okay, so on the one that doesn't say number 2, there are 2 of them, they are exactly the same. I'm just on the first one, it doesn't say 1, but it doesn't say 2. And we're going to very specifically do some problems, because while I don't think any of you are in danger of failing, there are a few of you who have maybe some issues with, honors diploma or something like that. So we're going to really, really focus on the ones that are going to help us get the highest score we can. Now, if you're shooting for an A on this exam, then you're going to need to do every single problem in here, okay? But this is going to be the core of what we need to know. So we need to simplify this. Who remembers how to do that? How do we simplify that? Well, okay, so you want to take care of that first?
Yeah.
All right, that is fine. Remember, though, that if you do that first, which is absolutely fine, everything moves exactly as it is. So don't be fixing any other negatives. If you are going to flip the fraction, because that's what that negative does, then the bottom goes to the top and the top goes to the bottom exactly as it is. Okay, you don't have to start that way, but that's a perfectly fine way to start. What else? Square everything. So if you square everything, that's going to be 25 x squared y to the negative 8th over 9 x to the negative 4th y to the 14th. That is not an exponent, so that number gets squared. The exponents get multiplied, right? Okay, now what? Again, the order we do it doesn't matter. That has to be done, so that's good. But now, you gotta combine like terms, so that you got the 25 and the 9, nothing happens there. But what happens to this guy? He goes up, so 4 are coming up, but there's already 2 up there. So we're gonna have 6. Now, some of you might say 2 minus negative 4, that's fine, it's 6. All right, and then these 8 are gonna come down, which means we're gonna have y to the 22nd. Now, the order you do that doesn't matter. Just be sure that that's the answer that you come up with. All right, C, simplify. Okay? Here we go. What do you notice about the top of that fraction?
Fraction. Oh, C.
Get factors. Guys. You're all happy to be here, remember? Focus. How does that factor? Sine minus 4 plus 1? Kids, that's a quadratic, right? So that's gonna factor. Tell me about cosine squared. What can you tell me about cosine squared? What's cosine squared equal? 1 minus sine squared. And what about 1 minus sine squared? It factors into 1 minus sine, 1 plus sine. Then these will cancel, and so your answer is just that. Now, keep in mind, I'm not teaching you anything today. You already tried that. I already tried to teach you. So now we're just alerting you to what you need to go back and study if you want to do well. All right, a problem like this. All right, find the number 2B. Find the exact value of the tangent of pi. Now remember, if there's no star next to it, it's a no calculator problem. So you're not just going to type that in on your calculator. This is no calculator. So what? we're gonna look at, well, what's pi? 180. So we're gonna look at our circle. Remember our labels. And when the angle is on, 180 is on the circle, then we're looking at this point right here. And that point is -1, 0. Tangent is y over x, or opposite over adjacent, y over x. So tangent is 0 over -1, which is 0.
I saw a sheet when you first pulled it up. You get a sheet on file? Like
That's what we're looking at right here.
Yeah.
Now, I'm not sure that's what I'm gonna give you. I gotta make sure it covers everything.
Oh.
All right. Cosecant 5 pi over 3, next problem. All right, what do we do with this? Cosecant 5 pi over 3. Well, what did we do here? We changed that pi into 180, into degrees. So see that pi right there? That's 180. When I divide it by 3, I get 60 times 5 is 300. So I'm looking for the cosecant of 300. I'm going to use the same circle I used there, but the difference is 300 is not on the axis, right? Right? It's between 270 and 360. So how big is this angle right here? That's the one that matters.
60.
That's gotta be 60 because that's 300, I need 60 more. And in a 30, 60, 90 triangle, the sides are those, but you gotta be paying attention because something's negative. What's negative? The root 3. The root 3 is negative because it's down in quadrant 4. Cosecant. Cosecant is reciprocal of sine. So it's hypotenuse over opposite, which would be 2 over negative root 3, or negative 2 root 3 over 3. All right. 4b. Remember, my job is not to teach you this. I already tried to do that. Hopefully I was reasonably successful. But it's over. I don't have time to teach it all again. We're just bringing it back to the surface so that those of you that are gonna study for the exam will have a base of stuff to study. All right, what do we do here? This is a logarithmic equation. What are we doing with this? Well, first of all, you can't have both of these on the same side. Yeah, you can't do it. So you're gonna put those together. Since that's a minus, I put them together as a division. If it were a plus, I'd put them together as a times. Right? Now, what do you think? What is your common sense telling you right now when you look at this equation? Well, I would do that if this weren't there. But since the log of that equals the log of that, doesn't it just make sense that those have to equal? So, Kara, we would definitely do the log roll or loop-de-loop, whatever you call it, if this weren't there. Because if I didn't have that in place, then I would have to do 5 to the 5th equals this. But since I have it here, I just drop them out. So x plus 3 equals 5x, 4x equals 3, and x equals 3/4. Remember guys, you're taking your exam in a regular class period. Okay? So it's like a regular test. Looks like a regular test.
What else would we take?
Alright. C. Still solving equations. 4 sine x equals 3. Now notice this one does have a star next to it. So we will be using our calculator, but not until we do what first? What are we gonna do first? Divide by 4. So sine x equals 3/4. Now, we gotta figure out what angle, x is an angle, what angle has a sine of 3/4? Well, before you go to the calculator, it's easy to find on the calculator, you've got to recall that it's in either quadrant 1 or quadrant 2, because sine is y, and y is positive in quadrant 1 and 2. Okay? So now I'll go to my calculator. Second sine 3/4, that's how I find an angle. I use second sine, and that angle is 48.59. Just second sine 3/4. Now, what are the actual answers to the problem then? There's 2 of them. There's one in quadrant 1, which won't that be 48.59? And then there's one in quadrant 2. And how will I find that one? 180 minus, yep. So that one is 131.41. So that's tricky because kids will immediately go to the calculator, which is fine, but you have to remember that you can also be in quadrant 2 with that one. All right, next, another equation, D. Now this one does not have a star. So what do you think you're going to do if it doesn't have a star? What? Well, yes, thank you, Kara. We're not going to use a calculator. What's going to be our strategy though?
Multiply by 2.
So remember that both 4 and 8 are powers of 2. So 4 is 2 squared and 8 is 2 cubed. So Emma, 2 was exactly what you wanted to focus in on. That both of those numbers can be written as powers of 2. Now, the test may not have a 4 and an 8. It may have a 9 and a 27, right? Or a 25 and a 125. Your job, if the problem looks like that and you don't have a calculator, then you've got to make those bases match. You got to figure it out so the bases match. Now, double exponent like that means multiply, so I'm doing a little distributive. And now tell me what your common sense says at this point. 2 to that power is exactly the same as 2 to that power. So the exponents are equal. It's just like a logarithm when we looked at a minute ago. So 5x equals -9. It looks like -9/5 if I did my arithmetic correctly. All right, now number 8.
What would you do for E?
Okay, right now, I'm zeroing in on the ones I absolutely need to get to.
Gotcha.
So I'm on problem 8. Okay? Now, find partial fractions, right? Who remembers this? What do we do with this?
Break it up.
So the first thing we do is factor that denominator, right? Correctly. Make sure you get it factored correctly. And then, yes, recognize you're looking for 2 little fractions, one of which has x minus 3 under it, and the other one has x plus 2 under it. I don't know what's on top, So traditionally, we call it A and B, you can call it whatever you want. Now what? So this is the common denominator, right? So if I want all the denominators to be the same, then this one needs an x plus 2, and this one needs an x minus 3. Now that isn't exactly the way I did it when I did it before, but she told me to get a common denominator, so that's what I'm doing. As soon as all the denominators match in an equation, as soon as they all match, you can ignore them. So what we have left is this. So yeah, you want to get rid of the denominators. I normally multiply through, Kara decided, make them all the same and then drop them. Perfect, doesn't matter. Result's the same. Now what? Well, make an equation out of like terms. So 10x, ax, bx. So 10 has to equal a plus b. And 5 has to equal the other parts, 2a minus 3b. So then what happens? We need to either, somehow you have to solve this. So you can substitute, eliminate, Kramer's rule, and whatever you want to do, you can do. I'm going to eliminate because I always eliminate. So I'll multiply the top one by 3. So 30 equals 3a plus 3b. Again, do whatever you're comfortable doing, but make sure that oh, that's not right, don't get that. Make sure that the number that's on top of x minus 3 is 7. And then the other number, the b number, will have to be 3. So make sure your answer looks just like that, because those are the partial fractions. Those are the two little fractions that add up to the big one. Okay, that's a no calculator problem. We didn't need a calculator for that. But we do need a calculator for the next one. We're looking at number 10. It says find A. And no, A does not mean area. It would say find area. If it meant area, this means find A. That's solid right there. Well, how do we find sides of triangles? We have these two terrific laws called the law of sines and the law of cosines. And they're on this sheet. They're the first two things on that sheet, the law of sines and the law of cosines. Now, you need to decide which one is appropriate for this problem. So take a look at what we got and tell me, are we going to do law of sines or law of cosines?
She's slipping the.
1,000,000,000% we're doing the law of sines, because anytime you have a pair like that, some of you are looking at it like you never heard this before. Oh my gosh, if you have this pair right here, that's going to be the law of sines. This is all 5,5 and 5,6. Go back to your notes if you have concerns. Sine 72 over 10 equals sine 58 over A. So I'm going to cross multiply. And then divide. So A is going to equal 10 sine 58 over sine 72. Now if you have an old-fashioned calculator like mine, when you hit 10 sine 58, you have to remember to physically close those parentheses before you do divided by sine 72. 8.92. I don't know what the rounding directions are going to be. We've talked about the exam, but we haven't actually written it yet. So I don't know what the rounding instructions will be, but you'll round it off to whatever you're supposed to round it off to. All right, 11. How many triangles are possible? Does anybody remember the options? 1 or none or 2, right? So how do we decide if we're 1 or none or 2? Well, guys, I want you to look at this picture, and I'm hoping your beady little eyes are looking at that,
I wouldn't say they're beady.
because they're gonna be black and blue if you're not careful.
Oh.
That means I'm gonna use the law of sines. So sine 79 over 15 equals sine E over 16. So I did the law of sines over here to find a side. Now I'm doing the law of sines to find an angle. So sine E, so multiply that 16 over here, is gonna be this. Now, do you remember what you type in? Second sine. So you are gonna second sine, that's how you find an angle. You are solving for an angle, you second sine this big fraction. Now, remember when we did this, sometimes it came up with an error message? What does that mean? No triangles possible. So let's see if we get lucky and get an error. Second sine, 16 sine 79, close parentheses, divided by 15 equals. Got an error. So that means how many triangles are possible? None. None. Now, let's just pretend for a moment that we got an answer. So when you type that in, instead of error, it came up as, I'm totally making this up, but let's say it came up as 84 degrees. Okay? Then you remember what you do? You check to see, you subtract that from 180, so that would be what, 70, no, 96? And you say to yourself, okay, if that was 84, then the second possible answer would be 180 minus that, which is 96. Can I have a 79 and a 96 in the same triangle? Yes. So that would be an example of where there were 2. If when you did this one came out to be 54, then this one would be 126. Would that be possible? No. So that would be an example of 1. But what happened with us was we got none. Now let's see what the next one is if it's fast. Yeah, we'll do 13B. 13B. And then that's the last one, and we'll go to lunch. 13B says find the determinant of C. So I just automatically started doing that because I'm in a hurry. Did you remember that's what you do? Okay? And then you're gonna multiply, and add all those up. So you do this, this, and this, and add them up. Then we do this, this, and this, and add those up. And then what? Subtract. I heard somebody say it. Subtract. So negative 2 minus 7. So the answer to the problem is negative 9. All right, we'll pick up after lunch back at 50. Please be back at 50.